this next video, we're going to be dealing with some basic operations of complex numbers. So this is going to be things like addition, subtraction, multiplication, and division, right? Just the basic standard usual math operations. We can do all of these with complex numbers. So one thing I wanted to address really quickly before we get started, complex numbers sometimes come with two parts. Okay, so we've seen in our previous couple of videos where you just have, if we scroll up, really just dealing with I times some real number. Okay, that's really what we're looking at here. Okay, so some real number times I, but really a complex number can have two parts to it. It can have something that we call the real part and the imaginary part. Okay, so let's take a look at just this complex number here. All right, let's ignore the minus and negative I. We'll deal with that in just a minute. But here we can look at this complex number. We actually look at this as a single number. We have 3 minus 5i. Okay, here we have the real part is the 3. So 3 is the real part, and negative 5i is the imaginary part. Okay, that's just a little bit of trivia, I guess you should probably know. This is the imaginary part of the complex number. Okay, so you typically want to group imaginary parts together and real parts together in order to get your final answer. Okay, and sometimes you just have the imaginary part. Okay, so that's just a little important piece of information to know. But when we're dealing with these problems, we want to, again, like I said a second ago, we're trying to group them together as much as possible. So let's do that here for the first example. So we're given the real number, 3 minus 5i minus a negative 5i. Okay, so the first thing we should notice is we have minus a negative 5i. That's the same thing as plus I. So this is really 3 minus 5i plus I. And therefore, we can actually just go ahead and eliminate those parentheses because we're just adding now. So we have 3 minus 5i plus I. So what we can do is we can combine like terms, so to speak. We can kind of think of this as like we're dealing with a variable. The I in this case is certainly not a variable, but you can think of it like one for how we do these operations, for now at least. Okay, for addition and subtraction, you can kind of think of it that way. Just as long as you understand this isn't a variable and you're not actually dealing with a variable, but it just kind of behaves like one in certain situations. Okay, so we're going to group these two together. So we have negative 5i plus I. That's going to be negative 4i. So we can rewrite 3 minus 5i plus I as 3 minus 4i. And that would be our final answer here. Okay? So let's do number 2 here. So we're going to treat this just like we would any other binomial. Okay? We're going to go ahead and distribute this negative sign across this parentheses here. So this is going to become 4 minus 6i minus 6i, and then we have negative times a negative 3i, so plus 3i. All right, and we can actually then also get rid of these parentheses now as well because we've dealt with that negative sign. So we have 4 minus 6i plus 3i. So let's combine, oh wait, this I shouldn't be here. Sorry about that. Really, that should be a negative 6. My bad. Sometimes we make mistakes. So we shouldn't have that either. So really it's 4 minus 6i minus 6 plus 3i. So we're going to group all of our like terms together. First, let's deal with the real component. Our real components are 4 and negative 6. So we have 4 plus a negative 6, and that gives us negative 2. And then we have negative 6 and 3 for our imaginary component. So negative 6i plus 3i. So that'll be minus 3i. So our answer here is negative 2 minus 3i. Okay, now let's look at number 3. Here we have negative 6i plus 5 minus 5i. Okay, so here, because we're dealing with just basic addition, we can actually just get rid of these parentheses, and it'll look like this. We'll have negative 6i plus 5 minus 5i. Okay, so now we can combine, we can go ahead and combine our like terms, so to speak, and we'll get, we have negative 6i, and we have negative 5i, so we'll have negative 11i plus 5, but it's customary to write the imaginary part second, so this is really 5 minus 11i. And again, negative 11i plus 5 is not technically wrong, but typically we write the imaginary part second and the real part first. So now let's deal with multiplication. This is where things can get a little bit more interesting, and you sort of have to stop treating I like some variable, okay? Up to this point, really, if we were to just replace I with X, it doesn't actually look a whole heck of a lot different than how it would normally be. But now we have to deal with the fact that we're actually dealing with an imaginary number and not just some variable here, okay? So we're still going to do a distribution here like normal. We're given negative 2i times negative 5 plus 5i in parentheses. So we'll do a distribution like normal. So let's go ahead and do that. Let's distribute the negative 2i to the negative 5 and to the 5i. Okay, so this is going to become negative 2i times a negative 5. So that'll be just a positive 10i. And then we'll have negative 2i times 5i. That'll be minus 10i squared. So we have the reason we have the square there is because we have negative 2i times 5i. We have two instances of I, so we have I squared. So we have 10i minus 10i squared. But 10i squared is just 10 times negative 1 because I squared is negative 1. So we have 10i minus 10 times negative 1. Or you can write this as 10i minus, really this will become just a plus 10, right? So 10i plus 10, or we do 10 plus 10i in order to keep the usual custom with complex numbers, okay? And the reason we're doing plus 10 is because we have minus a negative 10 here. So in this section, we have minus a negative 10. So it becomes 10 plus 10i. Okay, and here we can in our next example, example 5 here, we have 1 minus 3i, parentheses, times 2 minus 5i, in parentheses. So we can do our usual FOIL, okay? Hopefully you all have seen that before. That's firsts, outers, inners, and then lasts, okay? So we'll do that now. So we'll do 1 times 2. That's 2. We have 1 times a negative 5. Okay? So 1 times a negative 5i. That's minus 5i. Now we have negative 3i times 2. So we have minus 6i. And now we have negative 3i times a negative 5i. So that'll be plus 15i squared. All right? Let's combine like terms. So we have 2 minus 5i minus 6i. So this is 2 minus 11i plus 15i squared. But remember, 15i squared is just 15 times negative 1 because I squared is negative 1. So we have 2 minus 11i plus 15 times negative 1. So this is really the same thing as 2 minus 11i minus 15. So if we combine like terms here, let's write it out. We'll have 2 minus 11i minus 15. So this is really negative 13 minus 11i. Okay, so really it doesn't look too different, except when you have instances of I squared, you do have to deal with that and turn that I squared into a negative 1. Okay, I think the really tricky part here is with the division of complex numbers. Okay, this is where things can get a little bit messier, I have to admit. So here, I do want to introduce something real quick. So let me move these down. We have something that we use often called the conjugate of a complex number. So if we have a complex number a plus bi, okay, the this a little neater. So given a plus bi, the conjugate of a plus bi is a minus bi. Okay? And if you have the conjugate of a minus bi, will just be a plus bi. Okay, so if you're originally given a minus bi, it'll be a plus bi. The only thing you're doing when you're taking the conjugate of a complex number is you're just changing this sign here from positive to negative or negative to positive. Okay, so here you'd flip it back to a plus bi. All right, that's all you're doing. But what we have a really nice property if you multiply a complex number by its conjugate, you get something really cool. So let's show this here. Let's say we want to multiply a plus bi times a minus bi. Okay, so let's do this now. We have a times a. That will give us a squared. We have a times a negative bi. So we have minus a times bi, and then we have bi times a. So again, we have plus a times bi, and then we have bi times a negative bi. So we have minus b squared times I squared. Okay? But what you'll see here is this minus abi plus abi. Those will go away. And then now this I squared will just become a negative 1. So we have a squared minus b squared times negative 1. Or this is the same as a squared plus b squared. And so what you'll notice is actually we've done away with the I altogether. We just have a real number. That's what we're dealing with here. We've now eliminated the imaginary part of our real number by doing that. And so we can take this little fact here and do something quite clever. So let's look at here at number 6. Let's say we want to try to write 2i divided by negative 6 minus 5i as just a standard looking complex number where you don't have any you don't have different instances of I in the numerator and the denominator. You just have a standard looking complex number. Okay, where you just have one I. That's all you're dealing with here. We can do something very clever here to this particular expression. We can multiply it by the conjugate of the denominator over itself. Okay, so let me show you here. So first, let's take a look at the conjugate of the denominator. Okay, so let's find out what the conjugate of negative 6 minus 5i is. Okay, remember, all we're doing is we're changing the sign here. So this is going to become negative 6 plus 5i. And so now what we can do is we can rewrite this as 2i over negative 6 minus 5i times negative 6 plus 5i divided by negative 6 plus 5i. You might ask, well, how can we do this, right? That seems like a pretty big operation to do. And it kind of is, but really all you're doing is you're just rewriting this expression, okay? And the reason you're doing that is if you were to just look at this part here, you're actually just multiplying the whole thing by 1, right? You have negative 6 plus 5i divided by negative 6 plus 5i. So that's just equal to 1. You're just multiplying the whole equation, the whole expression times 1, just in a clever way. So that's how you can get away with that. And so now we can perform this operation here. So let's deal with the denominators first. Okay. So here we can go ahead and FOIL this. Okay. So we have negative 6 times negative 6. All right. That'll be 36. Then we have negative 6 times a positive 5i. So that's minus 30i. We have negative 5i times negative 6. That's plus 30i. And then we have negative 5i times positive 5i. That is minus 25i squared. Okay? And for the numerator, we can multiply this. We have 2i times negative 6 plus 5i. So we can just go ahead and distribute this 2i to the negative 6 into the 5i. So we'll have negative 12i, and then we'll have 2i times 5i. That will be plus 10i squared. Okay, cool. So let's go ahead and simplify this denominator as much as we can. In the denominator, we'll have, we'll just keep the numerator the same for now. Okay, in the denominator, we can eliminate this negative 30i and the 30i. So because you're just adding 30i to negative 30i. And so we'll have 36 minus 25i squared. But we know that I squared is just negative 1. So this is negative 25 times a negative 1. So really we have 36 plus 25, which is just 61. Okay, and what you might notice actually is you could, in theory, just take this particular formula here that we just derived. If you have a plus bi times a minus bi, you'll just end up with a squared plus b squared. All right, so really this is just 6 squared plus 5 squared. Okay, that's all we're looking at here, is 6 squared plus 5 squared. All right. So if you memorize this, if you have a complex number times its conjugate, it's just a squared plus b squared. That's all you're dealing with. So now we can simplify the numerator, and we'll have, so this 10i squared will just become a negative 10. So we'll have negative 10 minus 12i over 61. Okay, and usually it's customary with complex numbers to write this actually as the real and the complex part as separate. So we just write this as negative 10 over 61 minus 12 over 61i. So this would be our final answer. So let's do the same thing here. So let's take a look at number 7 here. We have negative 4 plus 2i divided by 2 plus 3i. So let's find out what the conjugate of our denominator. Conjugate of 2 plus 3i is 2 minus 3i. And again, this comes from the fact that we're just changing the sign in the complex number of just this sign. You're not dealing with the sign of the number out front of the real component. You're just changing the sign of the imaginary component. That's all you're doing. So we're going to rewrite negative 4 plus 2i over 2 plus 3i as negative 4 plus 2i over 2 plus 3i times 2 minus 3i over 2 minus 3i. Okay, and taking a look at the denominator here, we're actually just going to use this a squared plus b squared formula here. So we have here 2 is equal to a and 3 is equal to b. So we can write this as 2 squared plus 3 squared. And now let's deal with this numerator. So we'll just FOIL this out. So we have negative 4 times 2. So we have negative 8. All right. And then we have negative 4 times a negative 3i. That's plus 12i. And then we have 2i times 2. That's plus 4i. And we have 2i times a negative 3i. That's minus 6i squared. Okay. Let's deal with this denominator. So we have 2 squared plus 3 squared. So that's 4 plus 9. And now let's deal with the numerator. We have negative 8 plus 12i plus 4i. So we have negative 8 plus 16i. And then we have minus 6 times a negative 1, because I squared is negative 1. So this is going to be negative 8 plus 16i plus 6 over 13. Okay, so we can write this as negative 2 we have negative 2 plus 16i over 13. But we could just separate this into the real and imaginary components. So we'll have negative 2 over 13 plus 16 over 13i. And there's our final answer.